this video, I'd like to introduce 3 different concepts. First, we'll talk about distance, then we'll talk about the midpoint formula, and finally, we'll combine the idea of distance and circles together to come up with the equation of a circle. So first, let's just start with the distance between 2 points. Now, if you think about just driving up the road and you need to find out the distance between, say, Greenville and Montgomery, and you're driving on 65, then you can just subtract mile markers, right? Mile markers, say, 130 from mile marker minus mile marker 110, and that would give you like 20 miles, right? That's not the distance between Greenville and Montgomery, but you see what I'm saying. You can certainly just subtract. But when you're dealing with a point, an XY value and another XY value, it's not as simple as just subtracting, right? Because you have 2 different coordinates. You have an X coordinate and a Y coordinate. So I'm going to show you how we're going to handle this. And so what I want us to do is I want to think about, say, this point right here. And I'm trying to sketch it. There it is, that point right there. Now, what I mean by this point right here is notice it has the same X value as straight above it. So this point would be X2 is my X value, but it has the same Y value as this Y1, X1 point over here. So Y1. Now, why did I pick that point? Because I can make a triangle out of this. Look at this. And this is what we call a right triangle. Now, the distance between these 2 points at the bottom. So this distance right here, the bottom part of my triangle, I can calculate that by subtracting x2 minus x1, right? Just like the distance on the road, mile marker 130 from mile marker, 150 or something like that. That would give you 20 miles. This is the same thing. I'm going to subtract x's. Notice this distance right here doesn't have anything to do with x's. It has to do with y's, and that would be y2 minus y1, right? Now, if we take this triangle, pick it up, and just take it out of the xy axis, it would look similar to this, and you recognize this triangle. If I call this A and this B, and this is the hypotenuse, right? What is the hypotenuse? Hypotenuse is the side across from a 90-degree angle. You learned this in school, I promise. This is the Pythagorean theorem. A squared plus B squared equals C squared. Very important theorem that you learn in geometry. And you also discuss it in an algebra class, that if you have a side squared plus the other side squared, it always equals to the hypotenuse squared. So what's important is not which side you call A and B, but what side you call C is very important, and it always must equal C squared. Well, if I apply that to my picture right here, I'm going to have, let's apply it. So A, instead of calling this A down here, I'm going to call it x2 minus x1. And instead of calling this side B, I'm going to call it y2 minus y1. So watch what happens. I'm going to have my A is x2 minus x1 squared, plus I'm replacing B with my y values. That's y2 minus y1. Now, why are we squaring it? Because again, down here, the Pythagorean theorem says I'm supposed to square both of those. Equals, now, instead of calling this C over here, which is what Pythagorean theorem says to call it, I'm going to call it D. You know why? For distance. We're trying to figure out how long this line is. So that equals D squared. So there's a formula for distance right there. But it doesn't calculate distance, right? It calculates distance squared. So how can I get rid of that? Y'all know what to do. To get rid of a square root, you take the square root of both sides. Now, what you're supposed to do is put a plus or minus in front of one of the sides. Actually, you might not put it in front of that side. You might put it in front of this side, right? If you're trying to solve for D. But distance can't be a negative number. So I'm going to get rid of the plus or minus when I write my final answer, because you can't have a negative distance. Distance is always positive. So that tells me my formula is, and by the way, I'm switching sides on you, the square root of x2 minus x1 squared plus y2 minus y1 squared. Don't forget the squares. And it's real simple. You subtract your x's and square it, you subtract your y's and square it, and then take the square root of the final answer. But y'all, this is just a fancy version of the Pythagorean theorem. That's all this is. And this is the distance formula. And you need to be able to Well, you need to know the distance formula, and you also need to be able to use the distance formula. So take a minute, write that down, and just what it is. So I'm subtracting my x's and then squaring it. I'm subtracting my y's and then squaring it. I'm adding those things together and then under a big square root. So it's actually going to be really easy when we do a problem. So I'm going to switch to the next page, which is going to show you the formula again, and we're going to do a problem. So here we go. Notice in blue is the distance formula. That's the same formula we just proved. Right there for you, ready to use. And I want you to calculate the distance between these 2 points. And notice I have a point 2, -3, and another point -1, 5. Now what I'm going to do is I'm going to call this x1, y1, and I'm going to call this point x2, y2. Now, there's nothing in the rules that says the first one listed has to be your 1s and the second one listed has to be your 2s. If you wanted to call this x2, y2 and this x1, y1, that is perfectly fine. I just want to be consistent. So when I plug it in my formula, d equals the square root. Now notice what we're doing. The very first thing is I'm going to subtract my 2 x values. Okay, so I'm going to say 5 minus a negative, x's, -1 minus a minus 2. I can't speak. -1 minus 2 and then square it, right? So I just subtracted this x minus this x. It would have been perfectly okay to do 2 minus a -1 also. And the order you subtract them is when you use this formula, the order you subtract them in actually doesn't matter because you end up squaring the value. But I say get used to being consistent. Let's do x2 minus x1 and then square it plus, now I'm going to do the same thing with my y values. y2, which is going to be 5, minus y1, which is -3. So 5 minus a -3 squared. Now be very careful. When you're minusing a negative number, you know, you're going to have 2 negatives there. That's going to turn positive. So you have d equals the square root. -1 minus 2 is going to be -3. Then we're going to square it. 5 minus a -3 turns into 5 plus 3, right? Because this changed subtraction to addition and changed the sign of the next number. All right, so that's going to be 8 squared. Still under a square root. I'm going to keep simplifying. D is equal to, now -3 squared, y'all, is not -9. You have to square the 3 and the negative. That's positive 9 plus 8 squared is 8 times 8 is 64. Now here's a mistake students often make. You shouldn't. You must add these together first. I can't take the square root of 9 and say that's 3 and the square root of 64 and say that's 8 and do 3 plus 8 is 11. That's wrong. You must add 9 plus 64 first. So that's going to be the square root of 73. And if this radical will simplify, you should simplify it. But there is not a perfect square that divides evenly into 73. So this is what we call our exact answer. That is not rounded whatsoever. But you also need the skill of typing this in your calculator and getting a rounded answer. So let's try that. Now when I type in my calculator, I hit the second and the x squared button to get a square root, and then I type in 73 and push enter. And that gives me the value approximately, I'm just going to round 2 decimal places because my directions did not say where to round. If you're supposed to round, your directions will say where to round. But I got 8.544003745, and I rounded 2 decimal places to give me 8.544. But remember, this is a rounded answer. And if you're asked to round, be very careful about what decimal place you're supposed to round to. Another point I want to make is some calculators you have to type in your number first, 73, and then hit your square root button. So play around with that. Make sure you know how your calculator works. Okay, so let's try another one of these distance formula problems. My suggestion is when I flip to it, you pause the video, work it out yourself, and then just fast forward to the solution. And if you didn't get it right, then you can rewind it and see what you did wrong, okay? Now this one is a little different, right? Notice the square roots. Is it okay to have square roots as point values? Well, actually it is. You might not want to do it, but it's perfectly okay. Notice up here, tiny, I have the formula for you. There's the square root, the distance formula for you. I do need you to know it. Okay, you could use, of course, the formula in front of you now, but in the end, I need you to know this formula. Now, go ahead and pause it if you haven't. Work it out. See how it goes. If you're struggling with the square roots, of course, we'll talk about it when you come back. So how did it go? Let's find out. So you have distance equals the square root. I'm going to write the formula down. You know why? Because if I want to learn it, writing it down is the way to go. Write it down every time you use it. It also keeps you from making silly mistakes when you substitute. So x2 minus x1. Well, notice my x2 is the square root of 7 minus my x1, which is 0. And don't forget the square on the outside. Plus, now I'm going to subtract my y values. Well, my y2 is 0 minus my y1, which is, careful, negative square root of 2. And then you're supposed to square that subtraction. So make sure you're substituting correctly first. Don't do any calculations when you substitute. Just put it in there exactly the way it's supposed to be, so you make sure you have that first step right. Then simplify. So when you simplify next, you're actually subtracting. You're not squaring anything. Square root of 7 minus 0 is square root of 7. And then when we finish, we'll square it. Plus, okay, that's always a plus between these two. 0 minus a negative 2. These two negatives turn positive again, like the last problem. That's square root of 2 and then squared. Now, what happens when you square a square root? Well, they go away, right? They're like inverse operations of each other. So the square root of 7 squared is just 7. And, of course, the square root of 2 squared, for the same reason, is just 2. Now, don't take the square root of 7 and the square root of 2 separately. That's not the way to go. Neither is changing your pen color in the middle of the problem. So let's keep going. D equals the square root. 7 plus 2 is 9. That's still under our square root. Then your very last step is to simplify that square root if you possibly can. And in this case, we can. The square root of 9 is 3. Remember, in the last problem, we couldn't. The square root of 73 was just the square root of 73. It did not simplify. So that is your answer. There's no need to round since the answer is a nice whole number. The distance between those 2 points is 3. Now, if you really wanted a good feel for that, what did we just find? If I graph those points, 0, negative square root of 2. Now, square root of 2 is about negative 1.4. So 0, negative 1.4 is about there on my xy axis. Then square root of 7, 0. Now, square root of 7... I'm going to type that in my calculator to get a good idea. So square root of 7 gives me 2.6. So 2.60, what I just found was the distance between those 2 points right there, and we found out it was 3 units long. Okay? Now again, you don't have to plot these to get it done, but I wanted you to have an idea what you actually just did. And for our next problem, again, my advice, pause the video, calculate the distance on your own, simplify as much as you can, and come back and compare. All right, so let's get started. So I have D equals big square root, right? And I subtract my x values. So I've got a negative square root of 3 and a 2 square root of 3. I'm going to subtract those. Negative square root of 3 minus 2 square root of 3. Close out the parentheses, square it. Plus, now I'm going to subtract my y values. What are the y values? 5 square root of 6 minus square root of 6. And then close the parentheses and square it. And remember, all of that is under a big square root. So make a note of the important parts. I didn't write the formula down this time. You should have, okay? So I'm subtracting my x's. Make sure that's a subtraction. And then I'm squaring it. Make sure there's an addition sign between these two. I'm subtracting my y's and then squaring it. So let's simplify. Now, from a previous class, you should have learned how to handle this. If these were 2 different square roots, say this was square root of 5 and this was square root of 3, then I could not do what I'm about to do. But I can subtract these two using the coefficients in a front. That's a 1 right there. That's minus 1 square root of 3 minus 2 square root of 3. So think about the square root of 3 as your like terms, and then negative 1 minus 2 is negative 3 square root of 3. So I'm working with the numbers in front. Negative 1 minus 2 is negative 3. I keep the square root of 3, and then I square that number in a minute. Okay, now let's try this again. Again, this is a review of working with square roots. If you took Math 100, you should have learned that in there. If not, you learned it in one of your high school math classes, I promise. But there's a hidden 1 right here. Now, because both of these values are square roots of 6, it's like they're like radicals. So I'm going to work with 5 minus 1 gives me 4. So that's going to be 4 square root of 6. You keep the common square root of 6, and then we're going to square that. Now, when you square a square root, we've already determined that the square root and the square go away. But you also have to square this negative 3. So negative 3 to the second power is a positive 9. And the square root of 3 squared is 3. So notice I did each of those. The 2 went with the negative 3, and then the 2 went with the square root, and then the square root and the square cancel each other out when I take it with the square root. Let's try that again. So 4 to the second power is 16. The square root of 6 to the second power is just 6 because the square root and the square cancel each other out. Now remember, I'm supposed to continue to simplify, which means multiplication. 9 times 3 is 27, and then multiplication. 16 times 6 gives me 96. Use my calculator for that one. Next, don't take the square root of each of these. You must add them together. So this is D is equal to 27 plus 96 gives me 123. Now, if 123 had a perfect square that divided evenly into it, I would do that right now. So say if 9 divided into 123. It doesn't. But 9's a perfect square, 36 is a perfect square, 25 is a perfect square, but I don't know of a single perfect square that would divide into 123. 3 divides into 123, but it's not a perfect square. And then it's 3 times 41, and there is no perfect square that goes into there. So this is my final exact answer, because it won't simplify further. But if it did, I would be required to simplify it. And as a matter of fact, let me show you one down here at the bottom, just in case you end up with an answer like this, because we didn't have one that simplified further, but you got to have this skill. So let's say our answer, not this problem, a separate problem, we got D is equal to the square root of, let's say, 50. Well, there is a perfect square that divides evenly into 50. It's 25, right? So I could write this as the square root of 25 times the square root of 2, right? Because 25 times 2 is 50. Now, why did I do that? Because the square root of 25 is 5, and the square root of 2 does not simplify any further, and that would be your final answer. So always, always simplify square roots. If you can simplify them, they must be simplified. It's just like reducing a fraction to lowest terms. That is a required step. Now, I've got one more of these distance between 2 points problems for you. Now, really, you could have had it with me just showing you one example, right? But I wanted to show you examples that had lots of negatives, that had square roots, and we did 2 of those, and now, everybody's favorite, fractions. And so this is common. This happens all the time. We need to be able to work with fractions in the formula. So what do you want to do when you start the formula? Maybe just write it down. So D is equal to the square root of, subtract your x's squared plus subtract your y's squared, and all that's under a big square root. So there's my formula. Now I'm going to plug in. Okay, and don't lose any parts. Make sure you keep all of the symbols there. X2, which is going to be 3/4, minus X1, which is negative 1/4. Notice I wrote my minus and my negative, plus Y2, which is 6/7, minus Y1, which is negative 1/7. Another minus a negative number. Now, you know what they did? They made this problem easy for us. I know you're thinking fractions. Who said this was easy? Look, we already have a common denominator, y'all. That makes it real easy. 3/4. Remember, this is going to be a plus right here because of the 2 negatives. So that's 3/4 plus 1/4, which is 4/4. Now, yes, 4/4 is 1. We'll handle that in a minute. Plus, now 6/7, once again, I have 2 negatives right here. That's going to turn plus. So we're going to have 6/7 plus 1/7, which is 7/7. Don't forget the square. Hey, they made this even easier for us, didn't they? Because 4/4 is 1 squared, plus 7/7 is also 1. Still got to square it. The square root of, well, not yet, so d is equal to, now 1 squared is 1, plus 1 squared is 1. D is equal to the square root of 2. Will that simplify? No. Square root of 2 is it. Now, if you were asked to round, you could just type in the square root of 2 in your calculator. That's what I'm doing right now. And I get 1.41. So the distance is approximately 1.41 if I round 2 decimal places. But to me, the exact answer is the way to go. Of course, unless you're asked to round. But don't round just because you want to. Exact answer is the way to go unless you're asked to round. All right. Sorry about that. I don't know what that was. What about the center of a line segment? So I'm trying to find out where the middle of this thing is. And I'm not trying to move stuff around, which is what's happening right now because my pen's not working. Stand by. Now, I'm trying to find the center. That looks about like the center, right? But there's nothing official about what I just did. I just said, oh, that looks like the center. How could we find the center? Now, let's just say instead, not this problem over here, I'm trying to find the center between maybe 1 and 8. What's the center between 1 and 8? Or let's make it easier. What about the center between 1 and 9? Now, you could put it on a number line, right, to try to find the middle. Here's 1, 2, 3, 4, 5, 6, 7, 8. I didn't make it long enough. Let's go a little further. 9, right? There's the center between 1 and 9. Well, we haven't found the center. How could we find it? Well, you know, 1 and 9 go together. 2 and 8 go together. 3 and 7 go together. 4 and 6 go together. Ha! 5 is the center between 1 and 9. But then, remember a minute ago I had 1 and 8. That's not going to work so well, right? Because you're not going to have a number that just lands right in the middle. You're going to be halfway between two numbers. What's an easier way to do it? Well, how about we find the average? How do you find an average? You add them together and divide by how many you have. So add 1 plus 9, which of course is 10. 10 divided by 2 is 5. That's the center. You just add them together and divide by 2. Well, what about back on our picture over here? Well, I've got 2 different points, right? I've got an x value and a y value. Hey, what if we add the x's together and divide by 2? And then we add the y's together also and divide by 2. You know what? That will be that point right there in the center of the line. So all you got to do now, y'all, is average the x's and average the y's. So don't remember this formula as x1 plus x2 divided by 2. All formal-like. Just remember you average the x's together and you average the y's together, and that's going to give you the midpoint of a line segment. So let's try a few of these problems and see how we do. So here we go. There's the midpoint formula very officially instead of scribbled all over the page like I did just a minute ago. And what does it say? It says exactly what I told you. x1 plus x2 over 2, y1 plus y2 over 2. It says to find the midpoint, take the average of the 2 x coordinates and the average of the 2 y coordinates. That's all there really is to it. So let's try a problem. Okay, here we go. Example E. Find the midpoint of the line segment with the given endpoints. So what do I want to do? I want to average the x values together. Okay, so I got a -4 and a -1. I'm going to add, remember, add those together, divide by 2. Okay, so -4 plus a -1 divided by 2. And then I'm going to average the y's together, right? So I'm going to do y's average. How do you do that? Then you -7 plus -3 divided by 2, right? So I average the x's and average the y's. Now, -4 plus -1 is -5 divided by 2. -7 plus -3 is -10 divided by 2. Notice the comma I put between them? Because you know what? My answer is a point. It's the x value and the y value that's the average. Now, Negative 5/2 is a fraction in lowest terms. You don't need to write that as a mixed number unless you really want to see how big it is. It would be negative 2.5. But I'm looking for negative 5/2. And negative 10 divided by 2, don't leave it like that. We know that's negative 5, right? Now, you can write that as a decimal, but remember, unless you're asked to round, don't round. So negative 5/2 would be negative 2.5. Negative 5 is just negative 5. So both of these are appropriate answers, but typically you're asked to leave your answer in fraction form. Now, let me show you what that would look like on an XY axis just real quick, right over here. Now remember, our original point was negative 4, negative 7. I'm going to graph that, and let's do it in pink, okay? So negative 4, 2, 3, 4, negative 7, 1, 2, 3, 4, 5, 6, 7. I'm not doing a wonderful job of this. So there's your first point, negative 4, negative 7. The other one's negative 1, negative 3. So negative 1, negative 3. And we're trying to find the middle of that, okay? Well, look what we found. We found the answer negative 2.5. So negative 2.5, negative 5, right there. That's pretty close considering my really sloppy version of that point. But that's what we found. We found the middle of the line segment. So this is pretty easy. Average the x's, average the y's. Let's try another problem. And you're thinking, yeah, it's easy as long as she doesn't give me a bunch of fractions. But there she goes. Here's a bunch of fractions, right? Can we do this? Oh, yes, of course we can do this. So notice the formula says average the x's. So I'm going to come right out here, and I'm going to average my x's. So I'm going to take negative 2/5 and add that to negative 2/5. So negative 2/5 plus negative 2/5. How do you average? You divide by 2. It's like, oh my gosh. Yes, you can do this. And then average the y's. So 7/15 plus negative 4/15. And then divided by 2. Now, you know what? Honestly, they made it easy for us again. You know why? Because when I add negative 2/5 plus negative 2/5, I already have a common denominator. That's the hardest part about adding and subtracting fractions is when you don't have a common denominator. So no problem. Negative 2 plus negative 2 is negative 4/5. Don't forget, we got to divide that by 2. We'll handle that problem in a minute. 7/15 plus negative 4/15. Now remember, you're taking a positive and adding to a negative. That's going to give you 3/15 divided by 2. Now, how do you take a fraction and divide it by 2? Well, let me show you. Put that 2 over 1 for each of them, and then you invert and multiply. I'm going to flip those two guys upside down and multiply. So I have negative 4/5 times 1 over 2. And then for my y value, I have 3/15 also times 1 over 2. And I come over here to the right and finish this deal up. Now, here's something else I want you to see. This 2 and this 4 cancel each other out to leave a 2. So when I multiply, I could just say 4 times 1 and 5 times 2. That'd be 4 over 10 and then reduce. Or I could do what I just did in pink there, cancel those 2's and do negative 2 times 1 is negative 2 in the numerator. And then that just leaves 5 times 1 is 5 in the denominator. Here, nothing cancels. Actually, 3 over 15 would cancel. I could say, let's do our pink canceling again. 3 cancels here to make that a 1, and 3 goes into 15 5 times. And as long as you're doing a numerator, denominator, when you're multiplying, it can either be straight up and down or across like we did here. So 1 times 1 is 1, and 5 times 2 is 10. That is my midpoint, y'all. Now, we could plot this and do it, but I'm going to save you the grief of plotting this. I feel pretty good about our work here. So I'm checking from the beginning. Negative 2/5 and negative 2/5 is negative 4/5 divided by 2 would be negative 4/10, which is negative 2/5. And then 7/15 plus a negative 4/15 is going to be 3/15. Yes. And you could have reduced it right there and say that was 1/5 times 1 over 2, which is 1/10. Yep. Checked it. We did it right. Let's see if I have another one for you. Well, of course I do, and look at this lovely one. Okay, so find the midpoint of the line segment with the given endpoints. We've got square root of 50, comma, negative 6, and square root of 2, comma, 6. So remember your formula. You average the x's together. Let's do that. So when I average my x's, I'm going to take negative square root of 50 Actually, it's not negative, it's positive. Square root of 50, I'm going to add that to square root of 2 and then divide it by 2, right? And then I've got negative 6. I'm going to add to positive 6 and divide that by 2. You with me? Now, here's something weird about this problem, and I'm glad it popped up. You remember simplifying the square root of 50 earlier? Y'all, I picked that at random, but here we are with the square root of 50 right in front of us. I cannot add these two together, the square root of 50 plus the square root of 2, because they're not like radicals. When you add or subtract radicals, these guys have to match. They have to be both the same number under the radical, and that's called the argument. But I can simplify the square root of 50. Remember, over here to the left, I can write that as the square root of 25 times the square root of 2. And the square root of 25 is 5 times the square root of 2. So I'm going to replace that and watch what happens. I have 5 square root of 2 plus square root of 2. Then we're going to divide it by 2. And hey, over here on the right with the y's, we can go ahead and say negative 6 plus 6 is 0 divided by 2. And that will be 0 in just a minute. But back to our square roots, our unruly square roots. There's a 1 right there, right? So when I add these square roots together, 5 square root of 2 plus 1 square root of 2, that is 6 square root of 2 divided by 2. 0 divided by 2 is 0. Let's go ahead and get that over with. Now, right here, this 2 and this 6, I can say 2 goes into 6 3 times. And that is completely simplified when I write it again. 3 square root of 2 is my x value, and 0 is my y value. And you might be thinking, if I've got to plot that, I have no idea where that is. So just type in 3 times the square root of 2 in your calculator. And I'm doing that right now. And that gives me 4.24 if I round 2 decimal places. 4.24 comma 0. Now remember, this is rounded. Unless you're asked to round, you don't round. Okay, but if you need to know where that is on an XY axis, you might want to round it. So this is the exact answer. And of course, there's your rounded answer. So I'm going to wrap up this video now because, 30-something minutes is good for part 1. And then when you come back for part 2, we're going to talk strictly about circles. But you need this information to talk about circles. You definitely need to understand the distance formula before you move on to circles. Have a good one.